going to look at enVision's Algebra 2, Topic 5, Lesson 3. We're going to look at example 2, which starts going into the transformations of radical functions. So let's kind of look at basically the radical function and how this relates to transformations. Let's go back a couple of lessons and look at the different parts of a transformation. So we have the function f of x is equal to, I'm going to make this a nth root radical. And my transform function, which you guys know I call a child function, is going to be g of x. And there are certain parts to a transformation or a transformed function. We have a, which is multiplied to my radical. And a in my case is going to be a vertical scaling. So it's going to be a vertical stretch, or it's going to be a vertical compression, but this is going to be a vertical scaling of my function. So we are looking at a vertical stretch or compression. Or compression. And if a is greater than 1, it's going to be a stretch. And if a is less than 1, but greater than 0, because if you multiply 0 to anything, it's going to be 0, this is going to be a compression. All right. So in the radical, I have x minus. The equation or the transformation always has x minus. And so if this is going to be a plus here, that means that your h is either, it's going to be a negative h. And this h right here is my horizontal translation. And what that means, it's a left to right movement. Left or right movement. And then the last part of this is, again, we're moving outside the radicad. If it's outside the radicad, it's a vertical. If it's inside the radical, it's a horizontal. So I'm moving outside the radical, and I'm going to do the vertical translation. And again, this is the up and down. All right. So those are your different pieces of a transformation of a function. And if you need to pause the video here to write them down, please pause and write them down. Know this. This shows up over and over again with each type of function that we visited. We've seen this with quadratic functions. We've seen this with exponential functions. We are now seeing it with radical functions. So make sure you take the time to have this in your notes and to learn this, because transformations show up over and over and over again. All right. So let's look at example 2. Example 2, I need to move this over a little bit. There we go. Example 2 is looking at the transformation given a child function or a transformed function and what that looks like from the original function. So the function we are given is g of x let me get to my layer. G of x is equal to 2 times the square root of x plus 3 plus 5. So the first step I'm going to take, the first thing I'm going to do is I'm going to identify all the transformations that occurred on my function. So I'm going to see, is there an A? Is there a vertical stretch or compression? And we do. We have the number 2. 2 is greater than 1, so this is a vertical stretch. Which really means that you're going to take your y value and multiply that by 2. So every y value you have, when we're looking at the graph, you're going to multiply that by 2. Okay, you have an h. Remember that my original formula is x minus h, and we have a plus here. To get that positive, you're going to have to multiply the negative times a negative. So x minus a negative 3 would give us a positive 3. So our h in this case is negative 2. So we have a horizontal shift. Three units left. And if this is positive, you're going to go the opposite direction because you're instinctively wanting to go positive to the right, but really it's negative. It's a negative h. And the k is going to be 5. And this is vertical. Shift 5 units up. It's supposed to be graphs. How do the graphs domain? How do the graphs domain and range of G differ from those of F? So let's graph this. Let's see what this looks like. So here's my graph. Let me get my ruler. I'm going to draw a line here. My sound effects. Spin that around. If I'd planned that better, I would have had that dot there. It's not, there we go, quite straight. Draw that here. Okay, so my parent function I'm going to do in a bluish color. And I know it's a square root, so I'm going to do anything squared. So 0, so my parent function is going to be the square root of x. So 0, the square root of 0 is 0. Anything negative we don't have because that's the domain. The domain doesn't go for the parent function beyond 0. 1, the square root of 1 is 1. The square root of 2 is some ridiculous decimal. 3 is the same, but the square root of 4 is 2. 5, 6, 7, 8 are the same, but 9 is 3, and each block is 1 unit. That's 9, 10, 11, 12, 13, 14, 15, 16. 16 is 4. 1, 2, 3, 1, 2, 3, 4. Okay, the first thing I'm going to do is I'm going to take care of my horizontal shifts. I always do horizontals first. I always focus on horizontals first. That's a personal thing that I like to do. You don't have to start with horizontals. I personally just find them a little bit easier to do the horizontals and then do the verticals, since the verticals deal with the output, but the horizontals deal with the input. So each of these dots, I mean, I could connect the dots, but I'm not, just because I'm going to graph this. So each of these dots is going to be moved over 3, and I just realized my mistake is I didn't give enough room on my graph here. So this is 1, 2, and I'm going to go 3 right here. All right, so we're going left 3 units. So 1, 2, 3. Then we're going left 3 units. 1, 2, 3. Going left 3 units. 1, 2, 3. Going left 3. 1, 2, 3. All right, the next thing I'm going to do is I'm going to now multiply each of these. So I usually do the stretch compression and then the shift. So I'm going to multiply each of my output values by 2. So 0 times 2 is still 0. 1 times 2 is 2. 2 times 2 is 4. 1, 2, 3. 1, 2, 3, 4. What is that? 3 times 2 is 6. So 3, 4, 5, 6. 4 is 8. So 1, 2, 3, 4. So I'm just doubling that. All right, so there's my stretch. The pink rosy dots are my stretch. And now I'm going to shift everything up 5 units. So 1, 2, 3, 4, 5. There's only 1 unit to down and to the left, so I'm just going to put that there. 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So now here is a transformed function. If you remember, this blue right here was my parent function. And the domain and range, if you notice, the domain for my parent function is going to be x. X is greater than or equal to 0. And my range for my parent function is going to be y greater than or equal to 0. My g of x, so we're looking at 2 root x plus 3 plus 5. That is now going to be x, where x is greater than or equal to -3. Because here's my -3 here. I know you can't tell because I went off the graph. I didn't plan accordingly, but... And then y is greater than or equal to, well, we're up here at 1, 2, 3, 4, 5, if I counted that correctly, about 5, because we moved up 5 from here. Yeah, so 1, 2, 3, 4, 5, there's my domain. All right, so there are the differences between the two graphs, not gates. And so this is how I would graph it. You can also make a t-table. The book does pull out the t-table to show you how to do it through the t-table. I like throwing it on the graph and moving it up. T-tables are excellent as well. You can also take each part and put it into a t-table, and I have used them in the past, but I like throwing it onto the graph and start seeing how this is changed. All right. So there we go. There's our transformation of a graph.